What's up, YouTube? C#9 is an evolving language. It has almost every 6 months or a year, we have a new feature or a bunch of new features. Not all features are nice features. That's unfortunate. The language is such that there are so many features coming out. Most of us don't like half of them. At least I can speak for myself. Generally, in the last 2 or 3 versions of C#, I've just liked 1 or 2 features and that's it. Today's video, we're going to be talking about one of the features I do like in C#9, and that is the record type. Before we can jump into what a record type is and when to use, when not to use them, I need to set the stage with what do we do today without record types? What are the requirements we have today that record types are trying to satisfy and actually do fulfill, I think, quite well in C#9. So let's start with some little background information on reference types, value types, and semantics, equality semantics, okay, or value semantics for equality primarily. So I'm going to talk about that so you understand kind of the genesis of the need for what we do today, and then what and how record types help us in C#9, right? C#9 requires, in this case, Visual Studio 16.81 and above, of course, .NET 5, .NET Core 5. No, .NET 5, there's no core. .NET 5, all right. So if you don't have that, make sure you install those things before you start. This project that I show you here is a .NET 5, C#.NET 5 project, right? All right, so let's start with the basic class. This is a struct, not class, struct. This is a struct. It's got a bunch of properties. It's got a constructor where these things are assigned. Now, as structs are, these are value types, and we have here, I got an instance of a value type. I'm going to just create another instance. Let's call this blog post 2. And here, if I were to just equate these two, so if I were to say blog post 1 dot equals blog post 2. Now there's no equals operator for value types. So here equals, what do you think is going to happen if I were to run this with, let's watch. As you can see here, it is true. In other words, blog post 1 and blog post 2 are equal. What does that even mean from a struct's point of view? Structs use value semantics for equality, as in they treat two structs are considered the same if their values of all properties are the same. So that's known as value semantics versus reference semantics, where the two references have to be the same. They both have to be pointing to the same location in memory, right? Reference types use reference semantics. Value types use value semantics, especially from the perspective of equality, and copy semantics from the perspective of passing values to methods. That's value types. We're just more concerned with equality semantics today for this discussion. So value types give us this value equality out of the box. But is it free? It's free from the perspective that we don't have to write the code ourselves. It's not free from the perspective of performance. Value semantics in value types in .NET is implemented using reflection. So as much as it is free that we don't write any code for it ourselves, it's not free from the point of view of performance. So if you are concerned with performance, then you don't want to use this feature unless you override some of the equals, get hash code, all those kind of methods. And we'll talk about that for your value types as well. Okay, but it's not going to come for free. All right. So we saw that value types have this notion of value semantics. I want to change this to, from instead of being a struct, I wanted this to be a class. All right, so let's make this a class type. No change for the rest of the implementation here, but what you want to do here now is, it was true for value types. Let's see if this is true, the equals, and you can see here it's not, right? It's actually false. So we know this, we were expecting this, obviously. These are reference types. The references are not equal. Therefore, they are not equal. But for many, many years now, I've been using the notion of DTOs, or some people call them value objects. Either ways, value objects are objects that are treated with value semantics, very much like strings. Strings are reference types, are they not? Okay, good. So they're reference types. But strings use value semantics when it comes to equality, is it not? When we expect two strings to be equal, as long as their values, the string values are the same, isn't it? we don't expect them to, they could be, but we don't expect them to have the same references. We can have two completely different string objects in different locations in memory, and they're considered equal, right? Because the values are the same. So value objects are kind of treated like that. That's what they call. I call them DTOs. And if you haven't watched this one video I made a few weeks ago, I'll put a link to it over here, but I consider in my systems two kinds of classes, DTOs and behavior classes. DTOs are data only, they are immutable, they have no behavior, and then the behavior classes that have no state, no properties, but have only behavior. So I'm talking about the DTOs of the value type classes. My DTOs are immutable, right? And they generally will support value semantics when it comes to equality. So these are reference types, but I want them to be considering from an equality point of view, value semantics, meaning if the values are the same, I want them to be the same. So we do this in C# today before the C# 9 feature. I'll show you how that's done today. Okay. Before we go there, I just want, for those of you who are not quite familiar, I want to sort of explain this syntax here. It looks like it's a get only property. However, we are setting it in the constructor. So how's that actually working? Okay, this is a feature that was introduced in C# 7, I believe. It allows us in a little easier manner to declare or define immutable DTOs, right? And the way it's working is like this. I'm going to do this for the one property here. Behind the scenes, this is actually declaring a private read-only string property for, in this case, the title property, like that. It then implements the getter for this title property, like so. Okay. And in the constructor, it modifies this to be writing it to what is known as the backing field. Okay. This title variable here is known as the backing field. And it is read only specifically because we want this class to be immutable, which means you can write to this title backing field only in the constructor and nowhere else in the entire class. And the getter will return that value. So you set it in the constructor and the getter will return the value of the backing field, right? So behind the scenes, what do I mean behind the scenes? C# lowering. If you don't know what C# lowering, such a weird way to say it. C# lowering, lower, higher, lower. There's a video of mine. I'll put a link to that here on C# lowering. You might want to watch that. But basically the C# lowering step will rewrite the code like this for every one of these properties, even though we don't have to write the code ourselves. So it's nice syntactic sugar, as we call it. In these languages, we don't have to rewrite all the code, but it's important to understand that's what's happening behind the scenes. It's not magic. Well, maybe magic until you are told it's not. All right. So this is an immutable DTO. It's not going to implement the value semantics yet, as we noticed, or we've already checked out that they are not the same. These two instances here are not the same. So this is equated to false, but we want them to be the same because the values are the same, right? So towards that end, what we need to do here is in this class, we need to implement a few other methods, and this class also needs to implement an interface, right? So here are the methods. I'll discuss this. Let me just finish the coding here. And I just need to equatable of blog post. Oops. Blooper, blog post. All right. So what have I done? We had this constructor there before. Now we've done some of the things that we need to do. This is a standard. It's a convention. It's a guidance for implementing equality in C# when you want value type, value semantics. You overload the equals operator. You overload the not equals operator. In fact, one is just calling the other, as you can see here. The not equals operator is simply calling the equals with a not, right? So the basis you're implementing the equals operator correctly, and the not equals just negates that value of the result. Then you are required to implement the get hash code. In this case, all properties are participating in the hash code. Get hash code method is typically used when you stuff your DTOs or objects into the dictionaries hash tables, and to get that uniqueness and for the hash table to be able to find, first to determine if this is unique in the key, and secondly to find it again when it needs to, it uses this get hash code method. In this case, all properties as of now are participating. As of now, I mean, right now we only have these 4 properties. And then in the equals, again, there's these two methods, and then another equal here. And then in the equals also, all four properties are participating in the equality, okay, in this object. The deconstruct is not required, but I'm going to show you here what and why it's used or when it's used, because that becomes relevant to the C#9 feature we talk about as I build up the story here for the why and the how for this feature. So now, this blog post class that I defined now has a bunch of other implementation in order to support the notion of value semantics for equality. And so if I were to look back at this class, this code here, whereas earlier it was showing this to be false, and you can use the equals method as well. You don't need to use, the equals operator. You don't need to use since this is a class and we have the equals method on it. We can run this and you'll see that this time it's equating to true, which means that these two are now considered equals, even though they are two completely different references, are they not? These are two different references, but because their values are the same, they are considered equals because we implemented all this stuff for the equality. Make sense? Okay, now, if I were to add two more properties to this blog post, it is my responsibility to do all these things. I have to, of course, augment the constructor with the additional properties, define the additional properties, set the additional properties here. I need to make sure that those two properties are participating in the get hash code implementation here, like the four are currently. And I need to make sure that the two new properties are participating in the equals method as well. And of course, in the deconstruct, I'm going to have to do that as well. Same thing. So you add the signature, two arguments here, and implement them here as well. We'll get to what the deconstruct is for those who may not know that. So what I want to highlight here is the code is just busy code. There's a certain way in which to implement these methods, but there's a maintenance problem there when it comes to the adding of properties and making sure that those new properties are participating in the get hash code and the equals methods. And that may not be feasible. You could forget, you could introduce a bug simply because you forgot to add one more, property in your equals methods implementation. It's a bit of a headache there. But there are guidances for how to best implement or how to correctly implement the get hash codes, the equals method, and so on. So it's not like that's a problem, but it's just the maintenance part. And of course, because it's busy work, maybe something can help us with that. I'm building up to the C#9 feature. All right. The deconstruct feature or capability was introduced, I think, in C#7. The same version that we got, yes, I think C#7. But you could have a method return multiple types, multiple things, not just one thing. Typically, in other languages, including C#, if a method returns something, return one thing. But now you could return multiple things. And that is also being used, or is using the deconstruct feature or destructuring feature in C# as a language. What it really does here is it allows you, and I'll show you what it means. So let's say I have a blog post here. And because I have the deconstruct method implemented, I could potentially just do something like this. I could just say, that's the title. Then that's the author. I'm just going to do that. That's the post. And date. Let me just finish this out just so it's clear. And this is blog post 1 or 2 or whatever. Okay. What it's doing is it is taking this blog post and it's destructuring it into these different variables on the left-hand side. So if I were to run this application, you can see that the title is assigned to this variable here. The author's name is assigned to this variable. The post's data is here, and the date of the post is here. So this deconstruction is allowing you to kind of split up or break up a single, in this case, single class or instance variable to multiple properties. And this comes in handy in some cases, but the idea is that this feature has been around and it probably was introduced to support the idea that a method can return multiple types and then you can deconstruct it, if you will. On this side, we can say, okay, I'm calling a method, but it's returning 4 things, right? And that's how it works. And the the order typically in this case is of course determined by your implementation here. So title first, author second. So you need to know that. But if you have a constructor, which you typically do, then I would suggest just following the same sequence. They don't change that. So this is title, author, post, date. Your deconstruction should also be title, author, post, date, and so on. But it's something there that we don't do all the time. But it's nice to have features sometimes with your DTOs where you need to be able to deconstruct them in this fashion. And of course, you can choose if you want it. So in some cases, for example, say I don't care for the author. So I use the discard. Don't care for the post. This is your way of saying that I'm only interested in the title and the date. So the other stuff in the middle I don't care for. And so we use the discard operator for that. Okay. The other thing I want to bring up is the constructor. I'm a big fan of programming with intent, which means I would like to design my things, classes, systems, and write the code in a way that I show my intent very clearly. This class here is showing the intent by having a constructor that takes all the arguments. Essentially what I'm saying is, if I'm programming with intent, I'm saying essentially you cannot have an instance of a blog post without all these values set. It has no meaning to have an instance of a blog post without these properties set. Okay. Some people prefer to use the object initializer syntax, which is kind of like this. You put the curlies here, and then you start setting property of like that. To me, this is not programming with intent, because that's saying you can choose which properties to set and which ones not to, which typically for DTOs, that's not the case for me. My DTOs are very specific. They are very clear in what makes them valid. Generally, all properties are required for creating an instance of that DTO. Okay, but we'll get to this because you could implement this in C#9. There's a feature that was introduced in C#9 in order to support record types. I'm not a big fan of this feature. I don't really care for it, but it's there. You should know it's there. So I'm going to show you that feature. So since I'm programming in C#9, I could actually also just do this. I could just say this is init. Instead of set, we can have this init feature like that. All right. I'm just going to do it for the title case here. So if you look back here, you can see that in the case of the title, it actually allows me to set, of course, I do need the constructor. So it's not like I can skip that, but it is allowing me to set this. Oops. Set this property only because of the init, right? If the init was not here, it won't allow me, it won't like that. Right? It would actually be complaining here saying, oh, you can't do that. Okay. So the init only properties in C#9 allows you to set the property during the construction and or initialization phase of the class, which is either in the constructor or in the object initializer. Beyond that, you're not allowed. So for example, should I leave this alone here? I'm going to go back in and put this init thing here. Go back here. So it's allowing it here, but now let's say once I have an instance and I do blog post to .title and try and assign it here, it's still going to complain, hey, saying, what the heck are you doing here? You cannot do this because this is an init only property. All right? Do you follow? It's allowing me here now, but not here. If I didn't have the init, it wouldn't even allow me to do it here. Okay, let's look at that once again. So this was not an init only property. Then here also is going to complain about the issue. All right. Just a tidbit of information extra. I don't particularly care for the init only. I wish it was never there. For those of you who use the object initializers, you say, oh my God, that's pretty cool. I don't really care for it. Okay. Slight deviation from there. Oops. Okay. So we're back to square one with the deconstruction here. I'm going to remove the deconstruction. I'll let it be. That's fine. I want to just make this up here. So basically we're saying these two are equal. Okay. What about another way to get equality? What if I were to do JSON serializer dot serialize. Let's serialize this blog post one. And then I want to immediately deserialize that as well. So I'll just do it like a nested call here. JSON serialize.deserialize this back to a blog post from that. Okay, hopefully that makes sense to you guys. And here I'm going to have a variable, call it round-tripped blog. Okay, we've round-tripped it, meaning we've serialized it, and now we have a round-tripped blog instance. Will this blog instance be equal to blog post 1? And conceptually, if you're following value semantics correctly, those two should be equal. So let's verify that. So here again, I'm going to say is blog post 1, or conceptually I would say is round-tripped blog post equal to blog post 1. Oops. Right? It should be conceptually, since we took a blog post 1, we serialized it, then we deserialized it back to that. So these two should be equal in terms of their values. Right? So they should be set true, see true for this one and true for this one. Two console write lines, both should be true. Let's run that and run it. And there you see that they're both true, which means this actually works with our implementation of the equality. All right? Okay. So I'm hoping you understand the value of value semantics, the value of value equality when it comes to DTOs, which are reference types, but we want to treat them like value types and insofar as the equality is concerned, but not for other things. You can use structs for the same thing, one could argue, but structs have another, sometimes a feature, sometimes a drawback, which is copy semantics when it comes to passing as method arguments. If you pass these things across too many methods, you're making copies of it and copies of it and copies of it. That may not be the most beneficial way to send data across methods. Reference types then become sort of the better choice, where you have a reference in memory and you're simply sending a 4-byte pointer across different methods, but they all end up pointing to the same memory location. You're making copies of it. So with the understanding that we've decided to use classes for our DTOs to start with, then to get the notion of an immutable DTO that also supports copied semantics, this is the code that we have to write, which is the code I've been showing here. This is quite a bit of code, and there's a bit of a maintenance issue there to that. In C#9, watch very carefully what I do for C#9. I can make this a record. So what are records? Records are also reference types. They are classes, but they're records. They're reference types. Once you define a record, you can't treat it like a class in the sense that you can't have a class descend from the record, but you can have other records descend from this record. Okay. It took the C# team few years, long time, 8-9 years at least, to come up with this feature. I'm not saying they spent all their time just trying to figure this out, but there were a bunch of things they had to account for when it came to the idea or understanding of how does the classes and records, how do they play together in the same world, if you will, in the same universe. So we already have structs. Now we have classes, and now we have record types. What are these boundaries where they are the same, but they're not quite the same? Okay? Records are classes, they are reference types. They, by default, if it's a record, default implement value semantics when it comes to equality. We've done this by hand here, but basically they do that out of the box. You can, because they're classes, you can descend, and you can have descendants of a certain record type, but once you create a record type, or define a record type, it can't then become a class, right? So once it's a record type, it just remains in this world of record types. You can have other descendants of the record types, but that's about all it is. But for all intents and purposes, the syntax and everything else is the same. There are, of course, some new syntaxes that give us the benefit that I really like about records, but I'm going to show you here, this class, I can simply make it a record. Like that. Okay, now, of course, these methods are being overloaded. So I'm just going to remove this. Right, that's that. And here, okay, these are methods I have to comment out so you don't get confused with all these methods. I'm just going to comment this out. This is a record, right? Internal sealed record. these properties, the constructor, and that's it. I didn't implement all these things. I don't need to, and in some cases because it's complaining. But let me just leave it like that. Here's a record. It looks like a class. Instead of the word class here, it's the record, right? And if I were to look at the code on this end, the deconstruction is not working here because why is it not working? Since it is a record type, maybe it doesn't implement the deconstruction. I'll have to see why it's not supporting that. But let's just, for now, let's not worry about the deconstruction. We'll get back to that, but let's worry about the equality. So as you can see, we still have the same equality lines here, and we expect again that this right line should result in a true, and this right line should return or result in a true. So let's check that out. And we can see that they both are true, which means out of the box, record types give us the same value semantics as we are used to if we were using classes and DTOs that are immutable and support equality, value semantics equality. Then record types give us that just out of the box. By simply defining a record type, we got all that functionality out of the box, right? So okay, going back here. So you can declare class records like this, like classes, and then you can of course have descendants, meaning if this blog post was descending from some other class, then this whole inheritance, all that works just like classes. I personally strongly suggest you don't use records for that. Yes, it's possible the features there, but for me, my DTOs don't descend or inherit, and therefore I don't intend to ever use records like this with this whole hierarchy of descendants and getting all muddled up between, you know, classes and structs or class and record types. Even though the language, I think, has done a good job of supporting, I think, what you would expect to be done, it works as expected. But there could be situations where you get a bit muddled up. What I like about record types is this. You see this constructor here? Essentially, I want to take that and just declare that. So I could, over here, I could say internal sealed record, blah, blah. And I don't want this. All right, so that's all I got. Now, the one difference or caveat here you want to keep in mind is this ends up being, even though this is considered the primary constructor, this is a record type. It's called a positional record type, which means the declaration is this one-liner. There's no other declaration involved here. These are called positional record types. They have a certain additional feature, which I think is the deconstruct thing, but they also treat it slightly differently, just marginally different. For all intents and purposes, they're just records, right? And for these positional records and this primary constructor, as they're called here, this should be the property, not the argument. So basically, you're saying this is the name of the property, and so you want it to be Pascal cased instead of camel cased. Okay, that is on the call side. If I were to use, you know, a property here, so blog post 1.title, it's uppercased here because of the fact that it's uppercased over there. If I'd made this lowercased here, then you would see that the title property is not uppercase, but it's lowercased. All right. So now it's lowercased. Okay, it's not uppercase. That's what I was getting at. Okay, so it looks like a constructor. It is a constructor. However, the parameter name here is the property name and not the argument name. Okay, that's that. Okay, but other than that, and I think over here the deconstruction should be fine too, since yep, the deconstruction also works. Cool. So with the positional record types, you get the deconstruction out of the box. You get the value semantics out of the box. What else do you get out of the box? Anything else? Let's find out. What I'm going to do, I'm going to just copy all of this entire class file. I don't need the commented code, but I'm just going to copy that anyways. I'm going to go to sharplab.io. I'm going to paste all that code in here. I'm going to delete all the comment stuff here. So don't actually want to clutter this side. Not that it matters, it's commented, but take it out. Okay. So all I've got is the blog post record type declared here. And on the right hand side is the lowered C# lowered version of the code that the C# compiler has written for us before it does the full compilation into bytecode, IL, right? Look at this. This is a ton of code for the one line. It's a huge amount of code. Let's look at what it is. So first of all, we have the not equals operator. Yeah, the equals operator. That's cool. We had the same thing in our DTOs. We have the get hash code, and I'm guessing it implements. It's using the title property, the author property, the post, and the date property. Okay, so it's all there for the get hash code, using all the properties for the get hash code. This got the equals with the object type, and then it's got the equals strongly typed, in this case blog post. And the same thing here, the equals method is using all of the different properties, right? So at least it's got the equality related things already pre-implemented for us. Let's look at the top of this class here. It has the properties defined like this, where if you remember, we talked about the backing field. So there's a backing field here for the date type. That's our type backing field is declared up top, I'm sure. Here, these are all the backing fields for all the properties. And then each property is implemented where the getter returns the backing field. The set is not a set, but it's an init only property where it sets the backing field. And then we have the constructor, which is here, that internally is setting the backing field and so on. So from this one line of code here, we get all this stuff for free. Okay, so there's a few cool things here. One is they have pre-implemented the toString method here to give you a string representation of your instance, where it produces a string representation that looks kind of like JSON-like, with the curly brace open, curly brace close, and all the property values set up here. Okay, this is not the most efficient way to implement a toString, in the sense that there's a string builder being created each time. That means every time you use a toString method, instead of caching it and optimizing on that, like a whole new instance each time. Hopefully you don't use toStrings in production, do you? I hope not. A couple of years ago, there was a discussion going on at work where people said, do you use toString? Should you be using it in production code? And I said, oh no, toString is not to be used in production. It is a debugger only, or debug time, development time only feature, should not be used in production. I still believe in that. So for me, yes, during the debugging point, if you use a toString implementation like that, it doesn't really matter to me. But please don't use this in production then, or be careful, I guess. And then there is one other feature here, a couple of other features. Of course, got the deconstruct implemented, just like we had. It's using all the properties of the object, which is, I think, the cool part, right? This is a compile time feature, the lowering part, which means if I added 10 more properties, the code generated by the compiler for my record will automatically include those 10 new properties in the get hash code, in the equals, and in the deconstruct. It's just automatic, and the constructor arguments. So I don't have to manage and maintain that thing. I just maintain my record type here. If I add 10 more properties, I just add that to the constructor, and it just happens. Secondly, the equality is not using reflection, unlike with structs. So it's like you're getting the best of both worlds, right? You're getting all this code generated for you. You don't have to worry about writing all that stuff. And that is, to me, the beauty and the purpose of record types. You want reference types, but you want value semantics for equality. But you don't want the headache of having to maintain the equals method and the get hash code and all that for yourselves. And of course, all the class definition itself is so long. Here's one line, right? This one line translates to all this code. But wait, there's one more feature that is really cool. We don't do that, or we don't get that out of the box in C#. I use that using the builder pattern. If you remember this, I'll put a link over here for a video on the builder pattern. And there's some code on my GitHub that shows you how to use that. The idea is the same, but we'll talk about that feature as part of the records feature in C# and you get it out of the box. But let's talk about that later. Just here, I want to show you one more thing, which is this. There's another constructor here. There's a clone method and there's a constructor. The clone method is using this constructor, essentially saying, I want to create a new blog post with an existing blog post. And that's what this constructor here is. Now in C++, we would call this a copy constructor. I don't know what we call this in C#, but I would call it a copy constructor because that's what it's doing. We make a copy. Using a previous instance or a prior instance, we make a new instance, but making a copy from the older one, right? So typically in copy constructor in C++, you're basically trying to say, I just want to make a copy of this. And sometimes because it's a constructor, you want to literally use the data that came to you so that the caller can discard the instance that they have in hand because you used it to make a copy of it. All right. So that's the copy constructor. Now let's look at that feature that I was talking about with regards to copying. So if I went here to the code, let's say I want to create an instance of a blog post that looks kind of like this. Let's say, except the date I want it to be today is like current date for whatever reason, right? So I want to make a copy. A lot of the properties are the same. Now this is very important from an immutability standpoint, because when we have details in like the code we have today, and we have to make a change, we can't modify the immutable classes. So we make a copy with the minor change, right? So some things are all the same and some things change. That's the point here. I want to make a copy, except I want to change the date. Everything else should remain the same, but the date should be new. Or the author should change or something like that. So maybe author and date should change, because I'm going to show you that. There's a feature that's built into the record types in C#9. I could have a, what do I call this? I'm just going to call it copied blog post. Is equal to this copy from blog post 1. Blog post 1. This is then the with expression. And here is what we can say. We can say, okay, I want to make a copy from blog post 1. I want to assign it to a whole other instance called copied blog post. This is not a reference equality. This is a new instance. Since your thing is immutable, your record is immutable. It's a new instance of a record, using this one as the original kind of source in terms of the values of the properties only, right? And here I can say something like, I want to change the author to, let's say YouTube. And I want to change the date to something. I'm going to still say, datetime.now, but what I'm saying is I'm able to control the things. I could be able to use it then. Anyway, I can now use this copy blog post so I can see its value. I can write it. Remember, it's got the toString implementation. So when I do this write line like this, it should just write line using the toString here, right? And so you can see, I'll just run this application. So we will see here the DTO blog post. The title is my first blog post. Author is YouTube. Look at that. The date time is slightly different from before, but it copied all the other stuff. And that's the cool part here. With the with expression, we have the ability to make a copy very easily. It is a copy. There's a new reference being created. So it's not without its glitches, but that's the requirement, as in you want that. You need that feature. You want it to be that way. You want to create a new instance from a previous instance, copying all the properties that are coming in the older instance with some modifications to create your new instance. All right, makes sense? I'm hoping that makes sense. We do this all the time when we're using immutable DTOs. That's quite a common practice because they're immutable. But if you make changes to your data, you need to be able to make a copy of the data. That comes out of the box in C#9 with the with operator, with expression here. All right. So, and that's how you use it. So that brings us to the end of this video on record types. Please use them wisely. Please use them in the right place for the right things. Don't misuse them. I hope, I've shown you how I would use these classes with the positional record types. That's it. No descendants, no inheritance. So I hope you've enjoyed yourselves. I hope you learned a few things. If you have, please give me a thumbs up, and I will see you next time.